Sorry. Okay, so like I said, this is what we are looking at. And we'll be looking at the concept of data and big data. When we know what is data, we'll now see what we call big data. Hope we have been hearing big data, big data, big data. Can anybody just explain what you understand by that? Big data. Anybody? Massive information. Okay, big data could mean massive information. So let me give us a sample of big data. Let's say, let's say we are ordering food from Kilimanjaro. And once you place order for food in Kilimanjaro, their system where you place order is already there. Those on at the front desk, they key in the order. Someone at the back and a data analyst at the back is in front of the system. He can download an Excel sheet. The management would ask her, I want to know what kind of food people in Choba actually buy most. She will tell them that it is more of meat pie and probably pizza. That would inform Kilimanjaro that they don't need to be producing soup and eba every time. Or she tells them that every morning, based on data and not based on assumption, it's easy to come to class, or let's say they have a management meeting in Kilimanjaro and they want to plan their meal. Someone can easily come and say, since we are in a student environment, let's start cooking rice all through. And they keep cooking rice, and people are not ordering rice. But with the concept of big data, it means that every decision in an organization must be based on big data. What can you do with data? So you can test run. They can decide to cook all the menu for 1 week. After 1 week, they have a meeting, call the guy in charge of the system, give us the Excel list, let's analyze. He now sees that every morning, what sells most is yam and egg sauce. Every afternoon, what sells most is probably soup. Every evening, what sells is maybe porridge, yam, and bread. It will now inform the management that instead of producing eba in the morning, because you assume that Kilimanjaro is close to Choba campus, which is filled with engineering boys, and probably engineering boys will be chopping eba and akpu in the morning. That is based on assumption. But based on data, they can now do more of light snacks in the morning. Or based on data, they can now do more of eba and maybe egusi in the morning, because they notice that every Monday morning, that is what sells. That is why you go to some fast food, they will tell you, on Monday we sell ogbono. On Tuesday we sell maybe native soup. That is based on the user's behavior in that environment, based on data. Hope you are getting it. So data is very, very important. Very, very important. That is why you hear of census. Census. Hope you know what census is. Where you do head count. Like, I will probably need the data of the students in this class to print out examination scripts. I can't just go and print out 500 scripts when I only usually have 75. Or let's say it's time for exams, and I've been coming to class as a lecturer and I'm seeing only 60 people in class. And I print out 60 examination scripts. On that day of exam, I'm seeing 140 students. I'll simply say, I only have 60. Those of you that were not in class, you can't write, because I printed out the 60 based on the data that was available to me. Do we get that? So that is what this course is all about. Big data. How do we secure data? How do we manipulate data? What do we understand by data? So we'll be seeing how data evolved from traditional means to big data. We'll identify the characteristics of data. We are going to see the sources of data and how we can apply it. Then we'll also see how to apply information security to big data context. So this is actually what we are looking at today, from today to probably evening. So from the graph, we see that, no, not evening as per evening. So we see that from the 1960s, that is before the year 2000, data was actually structured, manageable, and centralized, because from the screen you see here, we just had limited data to play with. From year 2000, we had the era of social media. Facebook, emails, and all of them came to play. And that was when we stopped speaking in kilobytes. You know, before year 2000, we had floppy disks. Did any of you come to see floppy disks? You heard about it. Did anybody come to see it? No, some of you didn't see it. Floppy disks was just probably something like this. How will I put it? Maybe this size, yes. Floppy disk was this size. So those days, when you buy a computer system, you buy a floppy disk of this size and insert something on the system. If you want to buy games, maybe soccer, you are buying the floppy disk of the soccer and you insert into your system. So the size of the game was in kilobytes, 5 kilobytes, 10 kilobytes, because your entire computer system was probably 10 meg. That was all. When the year 2000s came, we started talking about gigabytes and terabytes. When we approached above 2000, we now had data explosion because of social media. Data was being harvested, and data was now used in real time to make decisions. From 2010 to present now, we have Internet of Things, sensors, data are being generated. Your mobile app, let me give you a scenario. Those of you that use Facebook, you notice that sometimes the adverts you see popping up on your Facebook could come up from the chats you are having with your colleague on WhatsApp. Am I right? You now be wondering what has happened. Facebook owns WhatsApp. So they have made sure they set a data algorithm such that whatever you are chatting, they see. And they use that to inform what you see as advert on Facebook. So data is now being analyzed in real time. What do we understand by big data? Big data refers to data sets that are very large, they are complex, and traditional data processing applications are inadequate to handle them. Why does it matter? We use big data to make better decisions. Companies use big data to outperform their competitors. Like I said, Kilimanjaro cook based on data. Maybe Mr. Biggs cook based on perception. Who would perform better? Kilimanjaro, because they avoid wastage. And due to customer behavior, they are able to now get things that people actually want. So big data and analyzing of data help companies to leverage and perform better than their competitors. Data helped us to develop new products, services, and new business models. The use of data enhances efficiency. Data helps us to predict. Data helps the country to predict when there will be flood. How do they predict it? They can predict when there will be heavy rainfall because they have equipment that monitor the cloud. And those equipments, the data is being analyzed by a supercomputer somewhere that can now predict that if maybe the stratosphere and others are moving at a particular speed, that can determine if there will be a rainfall at so and so time. And those data is very important for airplanes. For example, Facebook generates 4 petabytes of data per day. Google processes about 20. Twitter users alone send about 500 million tweets per day. And those are examples of big data. So the use of those data actually helps organizations to make several decisions. Now we are talking about 3 V's When we say 3 V's of big data, we are simply referring to the volume of the data. Velocity, what is the speed? Velocity in physics have to do with speed. What is the speed that this data is being generated and analyzed? Example, stock markets. Those of you that are into Forex, analysis of Forex is done per second per second. If you plug your internet and you are in the market and you just say, let you go and use the restroom, within that minute, the market can rise and fall and you can lose and gain. The third V of big data is called variety. Types of data structures. Types of data. Is your data a text data? Is it image? Is it video? Or is it data generated from several sensors? Aside 6V, we also have additional 3 to make 6 V's of data. We have veracity. Veracity has to do with the accuracy and quality of data. Value. What can you do with the data you acquire? Can you use the data to make a good business decision? For instance, let's say the hostel, based on, let me give you a typical scenario. Okay, yeah, let's say this now. In the hostel, the room's allocation was meant to be 1 person per room. 1 person per room. And based on the school assuming that 1 person per room will stay in the hostel, that is the same way they planned the water tank. And that is the same way they planned the sewage system. But it can come to a point whereby suddenly water is no longer enough in a particular hostel. Or let's say in your lodge, water is suddenly not enough. The sewage is getting filled up. What do you think has happened? Or what do you think will happen? The owner that is trying to work based on data, the owner that is trying to work based on data, he simply needs to get to the root of the problem. What will be the root of the problem? Take stock of the number of people in the room. When you take stock, you notice that the room occupancy is now, in a room of 30 flats, you are seeing 3 people per flat. 3 times 30 now gives rise to 90. That is why the sewage is no longer enough. He goes to his calculator and type, if 30 people per room is equal to so and so water, or so and so tanks of water per month, what do I need to generate a tank or a water flow that at least in a single day water will stay? The system will now tell him, work on maybe 6 GP tanks for that particular moment. That is now to say value. Value is, how do you turn data into business value? Now, the last V of data is variability. How consistent is your flow of data? Do you have a system to ensure that data flow or data generation is actually very, very consistent? That system could be survey forms. Maybe you are trying to improve the system of your organization, or the school is trying to improve light in the hostels. They keep sending survey forms to students. Can you feel right now there's light in school? As they are sending survey forms, they're asking students, what do you think about the light? How is the light feeling? You tell them every 6 p.m. there's no light. Based on that, they can feed back to the solar and say probably we need more battery in the solar farm in the university so that the light can last beyond 6 p.m. to 9 p.m. Please, are we getting it? That has to do with data flow. I'll show you something. Let me pause the recording and show you a particular slide. So these are the 6 V's of data, of big data. This is the explanation. I've already talked about it. The first one, volume. How many data can you generate? Let's say Netflix. Netflix can comfortably tell you that more than 1 billion people on earth watch on Netflix every 1 hour or by hour. What is the security implication? Storage. They would be overwhelmed with how do we store this information of these users. Velocity, how fast is your data transmitted. People use Twitter because they believe that Twitter is the fastest mode of chatting. Once you click, it has gone. And it has a platform that you can have real-time analysis of tweets. Variety, what are the formats of your data? In an hospital, they generate images because of maybe scans, they generate videos, and they generate sensors. What are the security implications? As cybersecurity students, you will know that those hospitals that generate several forms of data, that means they must have a form of encrypting and making sure this data is secure. You learned that in 200 level if you read your books of all the courses, forensics and all of that. So we are not going back to it. Veracity. What is the quality and accuracy of your data? In a university, the data you are generating from the students, how many percent contains error? Can we rely on the data you generate to make critical decisions? Very, very important. When you are collecting data from students, how accurate are your survey forms? Remember, every data collected is used to generate information. For instance, I can come to this class and ask us to fill a form on your computer literacy level. I must make sure I put the right fields in place. I can't just come and ask you, do you know computer, yes or no? What do you think you select? Yes. Yes or no? Even if you select yes, and I take it back to the organization that hired me, they can't use that data because possibly they wanted to be guided on what kind of trainings they can bring to this class. Do you know computer, yes or no? We will now tell them if they should bring computer appreciation training, web design training, data analytics training, maybe cybersecurity training. It won't help them. But if I come to this class and ask, tick the computer packages you know, you see all of them outlined. As you are ticking, it enables me to do a pie chart. And I can now know that if I'm proposing trainings for this class, 5 people should be trained on this area. 10 people should be trained on this area. If I suddenly come to this class and I want to teach, let's say, advanced Java programming, how many people do you think will flow? Nobody. I'm teaching it because everybody said they have computer knowledge. It won't be useful to you because I did not put the right principles in place when I was collecting those data. Value, I've explained that with this example. The variability, how can you vary your data that is being generated? I've used Kilimanjaro already. They are able to generate data of morning, afternoon, evening, and data of the weekdays. People's likeness for food may not be the same for morning, afternoon, evening. In fact, by the time they deal with the data, they'll even notice that students are using their fast food to plan their daily meals. Let me give you a scenario. When I was a student in Uniport then, like I always tell you guys, I was one of the poorest students. So when I'm giving maybe, I think 3,000 then as pocket money, since food, 3,000 to 5,000 I was giving, it depends. So food is the most important. I go to quality. I don't know if that fast food is still here. That fast food after NUH Block C, towards the back somewhere, PG Hostel, there's a fast food there called Quality. We'll go there. We'll carry about 2,500 or 3,000, plan with the woman. She'll give us her schedule for the week. We'll then say, okay, we'll eat 101. Or first meal is very important. We'll eat one. I was in medical science, so we'll learn from morning to night. First meal must be important. We'll eat 101. So, on Monday, we know it's banga stew and rice. We'll select that one. It means that from what we are doing, we have been able to work on data patterns. She now that is generating her data, she knows that students that like banga stew and rice on a Monday morning, they are much. Those that want, like we now will tell her we must shop eba in the night. She'll prepare eba in the night. People will come and say, why are you preparing? Maybe our friends or whoever will be saying, do you think students will eat this? She will say yes. Based on the data I have been able to generate. And based on the variety of my data, I can confidently tell you that my food will never get wasted. That is variety and variability of data that is generated. How are big data being generated? Number one, machine generated, that is GPS. As you use Google Map, do you know what Google Map is doing? So can someone explain to us how Google actually knows the accuracy of a place? Using your concept of big data we have explained up to this stage, how do Google actually know that this place is Choba, and when you use Google Map and say you're going to Uniport, it will tell you you have arrived and it will end the trip? How do you think Google Map knows that? Can someone help us? Can someone help us? No, just assume. Just attempt it, please. Using what? Okay, that's what you think. Can someone else assist us? Tell us what you think they use. Tell us what you think they use. How do they know that here is Choba? How do they know that there's even traffic in a particular place? How do you think they know that there's traffic? That when you're using Google Map, you suddenly see the place turning red. Explain. Let's hear from you. That's what you wanted to say. Okay, let's go practical. Google is the owner of Gmail. Am I right? And they are the owner of Google Search. When you leave your location on your Gmail, what do you think is happening? If you go to your Gmail setting, you notice that you can discover who is with your phone. Maybe if your phone is stolen, by simply using your Gmail. If you log into your Gmail on another system, it will tell you this email was last opened at so and so location because that your location is on. When 10 people are using Google Map in Choba Junction, Google has analyzed that data. If those 10 people are driving, maybe those 10 people plot on Google Map that they are going to Bayelsa and they put Amasoma, some other person may be Lagos, various places, but they're passing through a particular route. With their analysis in place, so far you are stationary, those data itself has formed a decision somewhere, telling Google, all these people are on Google Map, but at this location, all of them are suddenly there. It means there's a gridlock. When you use Google Map today and you say you are going to maybe ICTC building, Google may not necessarily know that place. It would assume. It will tell you it will take you 20 minutes to get there. But the map will wait to see your behavior. The map will be telling you ICTC building is a UPTH initially. It do happen. If you use Google Map well, you notice that sometimes it will take you to wrong locations. When it takes you there without turning off your Google Map, you that know the place, when you go to UPTH, you turn back and say, no, now, but this is ICTC. When you go to ICTC, you now close the map. The next thing, Google Map will tell you, is this the correct place, or did we help you get your location? You say no. Is this the correct place? Yes. It has marked it. Two other people coming to that same location and closing their app will tell Google Map to assume that this area is ICTC. That is how they don't have, fine, they have satellite, but those satellite can't cover everywhere at the same time. So they use consumer behaviors, consumers' behavior to plan their traffic and to develop and keep upgrading their mapping system. That is one example. Internet of Things sensors. Those vehicles like ESAID that have GPS enabled in them, those vehicles, GPS is always on. And some of the vehicles connected to internet. GPS constantly unconnected to internet generate various sensors on availability, server logs On my phone now, when we talk server logs, let me explain. For instance, on my phone, there's a place I supply internet to. So they suddenly called me that internet goes down. And I asked them, is your power on? They say our light is always on 247. How do I confirm the problem? On the internet, I have what is called logs. I go to the logs. The logs tell me connected so and so time, disconnected so and so time, uptime so and so time. From looking at the logs, it enabled me to trace yesterday that the problem was actually internal and not the client. Meanwhile, without this data, I'll call the person and say, can you turn off your phone? Like customer service, you call MTN, you cannot do it. They'll say, turn off your phone, remove your SIM card, clean it with spirit, do this one. The issue can never get resolved. But when you are looking at system logs, it can easily tell you that this issue may be here or there. CCTV footage. CCTV footage are sources of very big data, organization generated, financial transactions, government data, healthcare generates data. For instance, there's a man I met with yesterday. He came to me. He works with tuberculosis. I told him that we have a system that you can use to monitor malaria prevalence across Nigeria. He asked me, what system is that? Now, what did we do? We simply went to various hospitals and gave them forms. What were the forms doing? Anybody that come and complain for malaria, please log it in. If they get treated, log it in. That forms is going to a platform we designed where we are now seeing live data from several government-owned institutions. With that, now we can simply go to that dashboard and say that in Chioma community, we have probably 50 occurrence of malaria on a daily basis with only 10 being treated. Maybe because of that, it is lack to funding. The individuals don't have money. That means if government is now to give grants or to give free drugs to hospital, they simply need to visit that dashboard and say that Chioma needs that drug more than GRA. Do you understand this? That is how data, that's why data is very, very, very important. So data can also be generated by human beings. Humans are also big sources of data generation. Format of big data. How can big data be generated or stored? Structured big data, when we say structured, it means it is in a particular format. Maybe Excel, we have Excel sheets. Maybe CSV. CSV is another form of Excel sheet. Maybe it is being stored in a fixed database that can easily be queried. When we say query, just look at Excel. If you create an Excel and put serial number, names, see, look, listen to what I'm saying. You open an Excel, you put serial number, then a column, names, another column, date of birth. And I now tell you to filter everybody in this class by their first name. Is it possible, yes or no? Yes or no? Serial number, name, date of birth, gender. And I ask you, filter students in this class based on first name. Is it possible? Why is it possible? It's not possible. Why do I say it's not possible? This is the reason. When I give you forms to fill and I put a column called names, she may decide to write her name as, what's your surname? Surname? Johnson. Then what's your first name? Johnson Favor. He may now write his first name. Maybe she should use surname first, Favor second. He will go and write first name first, surname second. Another person may start in the middle. So you put your names based on the way you understand that question. Am I right? So if we now want to query that data and say, give me students organized by first name, it's difficult. You cannot just go to that field and say filter. That means your data is not structured because it cannot be queried. What do you now have to do? That means in planning to generate data, like me personally generating data, I try to be very detailed. Serial number, first name, middle name, last name, gender, date of birth, age. Put every possible field so that if I now want to query that information, I can just go to the field called surname. I filter alphabetically. Mat number, I filter by alphabetically. That is structured data. Semi-structured data has to do with log files. Log files are not usually structured. Like on my phone now, they just told me this device went out by 10:05 a.m. due to I cannot really get structured information from it. Unstructured information means that the data is in a form you cannot analyze. Images, video, audios, very, very complex to analyze. Small data versus big data. How do you relate them? Small data versus big data. How do you relate them? You relate them with reference to volume, storage, processing speed, structure, how you can analyze them, the speed of the data, the cost to generate the data, how data can be secure. Examples of small data. A company 5-year sales record could probably be 500 gig. Netflix, we are not talking about gig, we are taking of petabytes because assuming data is across several and several data centers. How data can be applied. I have already talked of that, so I'm going to skip it to read it up. I've told you healthcare, using application of data, you could predict diseases. Finance, you could predict fraud. Retail, I've told us that you could predict customer behavior and analytics. I've talked of transportation already. You could predict routes, predict traffic. Security and defense, you could easily predict cyber attacks and surveillance based on application of big data. Okay, application of big data. So what are the use case scenarios? Case study 1. We see a security operations center that receives probably 1 terabyte of log from, when you talk about log, let me explain what log is. What do I open now? Okay, let me do something to explain log. Just a minute, I'm trying to get something. Okay, so please let's look at the screen. This is a live, let's look at the screen. This is a live access control and surveillance system. This is a live access control and surveillance system that manages close to about 300 people in a facility. So with this system, people come in and out of the building. Remember, we were talking about use case scenarios. Use case scenarios. Now, I want to get to the log of this building, of this facility. I want to get to the log. Okay, look at this now. Look at this now. This is as at 16th. The system is telling me the people that keeps logging in at particular time, maybe the people that have logged in to a particular place and a particular door and access a device at a particular time. For instance, there's a particular location in this facility which we said out of bounds to staff. When I come and ask, how many of you went to this floor, maybe the 5th floor, everybody will say, I know, I did not know. I just have to come to the log. On the log, I'm going to see that we are seeing it here. Eyumere Ukpebo probably tried a card on that door to see it to open 3 consecutive times. She tried it again at another time. She tried it again. She tried it again. What is that telling me? It is telling me that there should be a possible, let's go back to our slide. It's telling me sorry. Okay, so it's telling me that probably there should be a threat because from getting the data, that system now gets data from all the access controls in that facility. And it is now telling me that based on those data, somebody is trying to access this facility. And based on that, I can now make some kind of informed decisions. I can make some kind of informed decisions. Why do big data matter for security professionals? Because the more the data we generate, the more the attack surface. What do you understand by attack surface? Attack surface. The more susceptible you are prone to attack. If Kilimanjaro, today they don't collect your names when you buy something, yes or no? Do they collect your names? No. You go to some fast foods that collect your name before they sell to you, or they tell you must have an account with us so that when you come, they know exactly what you want to order. Once Kilimanjaro starts collecting all your names before you place order for food, they have made themselves susceptible to attack. Which means that if I want to target Favor now, I need to find out where she's eating. If I ask her for her phone number, she don't give to me, I just need to go and attack Kilimanjaro and extract everybody's data just to get to her phone number. So the more data you generate, the more you make yourself susceptible to attack. If a hospital now start generating several personal data from you, it means that hackers can target that hospital to get patient records. If my organization probably start accepting payments with ATM card, it means that I have made myself a target of attack. Because by attacking me, you can have access to people's ATM card in case you want to take money from them. The more systems that are in an environment, the more vulnerabilities. The more users in an environment, the more access points available for attack. Because humans are the weakest line in security. Always remember that. Humans are the weakest line in security. The more complex a system is, the more misconfigurations likely to occur. I had a class with 200 level yesterday. We were talking about CIA triad. Hope you still remember CIA triad. Who can tell me? Confidentiality, availability, and what? Integrity. I asked them a question, which I don't think I asked you guys. I told them, can you give me a scenario where application of various CIA threats at a particular time can cause a problem? Who can answer that question? Application of several aspects of the CIA threat or several CIA threats. Maybe you are trying to apply confidentiality, integrity, availability at the same time, and it causes a problem in an organization. Can you give me a scenario where that can happen? Can someone give me a scenario where that can happen? Application of CIA tried. Okay, in order not to waste time, let's give a practical scenario. As the IT person in an organization, you want to ensure that the hospital is very, very secure. Patient records. The front desk office should only access their name. Accountants should only access their account details, right, without accessing their personal information. You now say doctors should access probably only patients assigned to you, yes or no? You now say the MD should be able to access maybe all the information. Now, the IT people working on the internet, in the operating room, they are told that X-ray machines or equipment in the operating room can have interference where there is internet. That means in the operating room, they have told them, don't give access, don't enable internet access once operation is going on, so that all other equipment can function. Have you heard of that before? Have you heard of that? When you are going to an operating room where they say put off your phones or something because of signal. Now, the guy that developed the hospital management system, for it to be very secure, he said that when you put in your username and password, it will send you a password to your email. When you enter the one sent to your email, it will now send another one to your WhatsApp. Then, like banks, you have to press token. We come to the operating room now. What has happened? The surgeon is operating, and suddenly things go out of hand. He now needs to get the blood group of the patient's line in front of him. How does he get the blood group? On the hospital management system. The MD is attending to business that has to do with money somewhere. He logs into the system. It has sent him an email with the password. There's no internet access. Someone's life is in his hands. What has happened there? The cybersecurity IT professional, in trying to be extra professional, has implemented integrity and confidentiality of information. And also in his own mind, is implementing availability because inverter power is on. But he has forgotten that a case may come whereby a record may be needed and internet access won't be available. That means in trying to implement all aspects of the CIA triad, he has killed someone. Can we see where application of everything becomes an issue? So in that case, I advise the classes today, as a cybersecurity professional, probably you are the one to plan the policies. What should you do? Always discuss first with all available units to know in detail what is to happen in your organization before you draw out your standard operating procedure. That SOP will now guide you to draw what we usually call maybe product requirement document, PRD document. That document now guide you to develop your policies, your processes, to develop your applications, and also to design your network so that you can take into consideration every detail that comes into play. Is that clear? So that, please, do you understand the example I just gave? So that is where application of everything sometimes become a problem in an organization. Application of all those things sometimes become a problem in an organization. So you must be able to have comprehensive visibility. Big data helps us to have comprehensive visibility among entire infrastructure in a facility.